Hello, welcome to The Extraordinary, where we are committed to the relentless pursuit of excellence. If you love tech and you like to skill up or learn something new, do like and subscribe so you don't miss any of our content. Today, we are going to be wrapping up on the data structures topic for Python. We are going to just read through the last two subtopics: more conditions and comparing sequences and other types. You can go back to them and go through the coding, the code sections. The condition used in while and if statements can contain any operator, not just comparisons. The comparison operator in and not in are membership tests that determine whether a value is in or not in a container. The operator is and is not compare whether two objects are really the same object. All comparison operators have the same priority, which is lower than that of all numeric operators. Comparison can be chained. For example, A less than B equal to C tests that A is less than B, and moreover, B is equal to C. Comparisons may be combined with the Boolean operators and or, and the outcome of a comparison or of any other Boolean expression may be negated with not. These have lower priorities than comparison operators. Between them, not has the highest priority and or the lowest, so that A and not B or C is equivalent to A and not B or C. As always, parentheses can be used to express the desired composition. The Boolean operators and or are so-called short-circuit operators. Their arguments are evaluated from left to right, and evaluation stops as soon as the outcome is determined. For example, if A and C are both true, but B is false, A and B and C does not evaluate the expression C. When used in a general value, not as a Boolean, the return value of a short-circuit operator is the last evaluated argument. It is possible to assign the result of a comparison or other Boolean expression to a variable. For example, so here we see that we are assigning empty string to string 1, Trondheim to string 2, hammer dance to string 3. So if we check here and we do our Boolean comparison, we are saying string 1 or string 2 or string 3. The value of these would be assigned to not null, and the value of this would be Trondheim, because of what we said here, that when used as a general value and not Boolean, the return value of a short-circuit operator is the last evaluated argument. So that's why we have Trondheim here. Comparing sequence and other types. Sequence objects typically may be compared to other objects with the same sequence type. The comparison uses lexicographical ordering. First, the first two items are compared, and if they differ, this determines the outcome of the comparison. If they are equal, the next two items are compared, and so on, until either sequence is exhausted. If two items to be compared are themselves sequences of the same type, the lexicographical comparison is carried out recursively. If all items of two sequences compare equal, the sequences are considered equal. If one sequence is an initial subsequence of the other, the shorter sequence is the smaller, lesser one. Lexicographical ordering for strings uses the Unicode point number to order individual characters. Some examples of comparison between sequences of the same type. So 1, 2, 3 is less than 1, 2, 4. Why? Because we would compare 1 and 1, which are the same, 1 and 2, which are the same, but 3 is less than 4. So this tuple here is less than this tuple. And same for this, we have a list of 1, 2, 3 and 1, 2, 4. 1 and 1 are equal, 2 and 2 are equal, but 3 is less than 4. The string in this string is also in this order. They are in this order. A, B, C is less than C, which is less than Pascal, which is less than Python. Why? Because the Unicode for C is greater than that of A, because the first character would be compared with the first character here, and C is greater than that of A, and the first character for P is greater than that of C, so P is going to be greater. And then the same thing here is P and P are the same, but Y is greater than A, so this would be greater. We're continuing. We have 1, 2, 3. First character is the same. The first item in the tuple is the same. The second is the same, but 3 is less than 4. So this is less. This tuple is less than this tuple here. This tuple here is greater than this tuple here. Same thing here. 1 is the same as this, and 2 is the same as this, but this tuple in size, it is less than this tuple here. 1, 2, 3, this tuple is equal to 1.0, 2.0, and 3.0. They are equivalent to each other. And 1, 2, AA, AB is less than 1, 2, ABC, A, and 4. Note that comparing objects of different types with greater than or less than is legal, provided that the objects have appropriate comparison methods. For example, mixed numeric types are compared according to their numeric value. So 0 equals 0.0, etc. Otherwise, rather than providing an arbitrary ordering, the interpreter will raise a type error exception. So that's it for data structures. Subsequently, we're going to be going to the next topic in our next episode. If you enjoyed the content, remember to like and subscribe, and I'll see you in the next one. Bye.